Okay, question number 4. Starting to get serious. You might look at this and think, oh my god, what the hell is that? Which would be a reasonable reaction, but don't panic, it's fine. You might notice or think, that looks a little bit like a quadratic, just like not the right powers, because you know that a quarter squared equals a half. Sort of looks like a quadratic. We want to use that, okay? That's what we want to get to. So there's a nice little trick that you can use, which if it's not already in your maths toolbox, you need to add it because it's really, really handy. So what we want to do is pick another letter. We'll pick X because everyone likes X, and say, ooh, attached, and say that Y to the power of a quarter equals X. Okay, we're just going to say that, and that's fine. Because now, if we sub this into here, we're going to end up with a lovely quadratic, which is a lot easier to work with than these horrible powers that you can't do anything with. So, if X equals Y to the power of a quarter, that means Y to the power of a half is X squared. So this is going to become 2x squared minus 7x plus 3 equals 0. And hooray, we know what to do with that. So now we just solve that like a normal quadratic. So you lay out your brackets with your 2x and your x. Again, we're looking for two numbers that multiply together to give 3, add together to give minus 7, taking into account this 2. So we can either have 1 and 3 or minus 1 and minus 3. They're the only numbers that will multiply together to give 3. So this is the minus 7, so we obviously want this negative pair rather than the positive pair, and then you just got to make sure you put the right number in the right bracket. So to get minus 7, we're going to have to times the minus 3 by 2 to get minus 6. And then we'll have another minus 1, which will give us the minus 7. So because we're timesing the minus 3 by 2, that goes in this bracket, because when you multiply it out, you'll do 2 times minus 3. And the minus 1 goes here. So then we need to work out which values of x will make these brackets equal 0, so that the whole thing equals 0. So in here, if x equals, we want this 2x to equal 1, so x must equal a half. If you do 2 times a half, you get 1, take away that 1, you get 0. And then in this bracket, for that to equal 0, x must equal 3, because 3 take away 3 is 0. Okay, so now we know what x is. We need to work out what that means y to the power of a quarter is, because remember we just kind of arbitrarily subbed that in, which is fine to do, but we need to work out what y actually is instead of this random x that we put in. So if y to the power of a quarter equals x, that means that because that's to the power of a quarter, like it's no good trying to work out what like the quarter root of a half is. It's just like not going to happen. So we need to, what's the word for it? There's no word for it. Square, cube, and then there's nothing for 4. But we want to do y to the power of a quarter, all to the power of 4, is just going to cancel out and give us y. So what we're going to have is y equals x to the power of 4. Because if you do something to one side, you have to do it to the other. So because we've put this thing to the power of 4, it's fine to do that, but we need to put x to the power of 4 as well. So y is either going to equal a half to the power of 4, because we've worked out our values of x, and that just equals 1 over 2 to the power of 4, which equals 1 over 16. Or y equals 3 to the power of 4, which is our other potential value of x, and that equals 81. So those are our answers. Y equals 1 over 16 or y equals 81. Now it's difficult because that might not pop into your mind, but it's by far the easiest way of doing it. If you try and do anything else, like squaring this whole thing, for example, you can do it sort of by brute force, but it's just going to be so messy and so horrible, and you're going to be multiplying out some huge numbers without a calculator because it's a non-calculator paper, and it's just going to be really difficult, and you're sort of leaving yourself quite open to making mistakes. So if this is all new and alien to you, that's fine. It's just something new that you've learned, and if you already know how to do it, that's great. You've just got to recognise that that's what you've got to do in the exam. It's all about picking the right method, basically, from the methods that you know. Yeah, so that's question 4. I mean, I could go through what would happen if you just squared that whole thing out. In fact, yeah, let's do it. It's just not going to be very nice. So rub this off. God, it's a right pain being left-handed, I'll tell you. I'm on the wrong side of the board all the time, but hopefully you can still see and it's fine. Yeah, so we want to at least try and be clever with it so that we're not trying to square this whole thing, we're just trying to square 2 of the terms. So if we write it, if we take this one, this minus 7y to the quarter over the other side, then we've got 2y to the power of a half plus 3 equals 7y to the power of a quarter. And then we're only squaring 2 of the terms, so it's just it's a little bit easier. So let's square this then. So we're going to end up with 2y to the power of a half plus 3 times 2y to the power of a half plus 3, and that's going to equal, square this whole thing, and we're going to get 49y to the power of a half, because if you imagine you've got 7y to the power of a quarter, so if you square all of that, the 7's going to get squared to 49, and where you've got this, a power raised to another power, you multiply the powers together, so a quarter times 2 gives you a half, so that's going to be y to the power of a half. That's where we get that from. Right, let's try and sort this out. So we've got 2y to the power of a half times 2y to the power of a half. That's going to give us 4y, because so when you're timesing powers together, or x or y or whatever to the power of something together, you add to the powers. So a half plus a half equals 1, so that's why we get 4y. And then we're going to have that times that is plus 6y to the power of a half. 3 times 2y to the power of a half is another plus 6y to the power of a half. And then 3 times 3 is plus 9 on the end. And that equals our 49y to the power of a half. So let's simplify this a little bit. So we've got 4y plus 12y to the power of a half plus 9 equals 49y to the power of a half. Okay, so we're still not quite there. We've still got fractional powers, which is not what we want. So we're going to do the same thing again so that we're not squaring this whole thing. We're going to take that 12y to the power of a half, take that away from both sides, or move it over to the other side, however you want to think about it. So we've got 4y plus 9. 49 times, take away 12 is going to give you 49, 39, 37y to the power of a half. And then we've got to square the whole thing again to try and get rid of that. So 4y plus 9 times 4y plus 9 because again, if you're squaring one side, you've got to square the other. Anything you do to one side, you have to do to the other side. That's going to equal, see, this is why you don't want to use this method, because who knows what 37 squared is? I certainly don't. You'd have to work it out longhand if you're in the exam, but I'm just going to use my calculator. So 37 squared is, oh gosh, it is 1,369y. Isn't that lovely? This is why you don't want to do this. So on this side, we're going to have 16y squared. 4y times 9 is going to give you plus 36y. 9 times 4y, another 36y. And then 9 times 9 is 81. And that's going to equal your lovely 1,369y. So, right, let's put it into a quadratic form then. So we've got 16y squared. Oh, I'm going to use my calculator again, sorry. So you're taking this away from this. So 36 plus 36, that's adding them two together, is 72. Then you've got to do 72, take away 1,369. So that's minus 1,297y plus 81 equals 0. And then you've got to somehow factorise that, which is just horrible. I'm winging this, so I'm not sure what the answer is. Oh, geez. So that 81, you could have, well, you could have 81 and 1, or you could have 9 and 9, or the negatives, so minus 81, minus 1, minus 9, and minus 9. So again, because this is just horrible, I'm just to make it a bit quicker, I'm just going to use my calculator again. So, oh, okay, we've got it. So again, it's difficult because this 16 you need to play around with as well, because you need the two numbers to multiply together to get 81, but then you need them to add together to get minus 1,297, but that's taking into account this 16, and you can factorise that in lots of different ways. You could have a 16x and, oh sorry, y, a 16y and a y. You could have an 8y and a 2y. You could have a 4y and a 4y. So it's just extra to work out, which makes it trickier and longer. So luckily what I just did on my calculator that worked. You wouldn't have that luxury in the exam. I know that it's going to be a 16y and a y, and that 16 times minus 81 gives minus 1,296. So then taking off that extra one is going to get you your minus 1,297. So we put the minus 81 in here and the plus 1 in here. Oh, sorry, the minus 1 in here. Oh. That equals 0. So then y, for this bracket to equal 0, y would have to equal 1 over 16, because 1 over 16 times 16 is 1, take away 1 gives you 0, or y equals 81, which would make this bracket equal 0. So you get the same answer, but there's just so much more room for error, and it's horrible. So just try, I mean, take comfort in the fact that if you can't remember how to do the first one, you can do this and it will work. It will just be more painful, but it's still fine. You'd still get the marks, which is the main thing, but try and have a go at the first one if it makes sense to you.